Math 242, Cuesta College. I'm Joe Vasta, and we are covering section 7.3, Parabolas. So we've seen parabolas before, and we've graphed them in earlier chapters. So what's so different about this section? The difference with this section is we learn a little bit more about parabolas. And we find out that a parabola is created from a line and a point. And that's what determines a parabola. So let's go ahead and take a look at a definition. This definition right here. See how it's coming out. Will be good enough. If it's too blurry, you can get the notes on the website in PDF form. A chord is the line segment joining two points on a curve. So an example of a chord from an earlier curve would be the diameter of a circle. It joins 2 points on that circle. Let F be a point. So that's what we're going to call this point, F. And let D be a line not containing F. So we'll call it line D. A parabola is the set of points satisfying the following. A point is on the parabola if its distance to F equals its distance to D. Now when we say its distance to D, we mean the shortest distance, the perpendicular distance. So for instance, let's make our parabola in blue. This point right here looks like its distance from F is the same as the distance from D. So, so I'll draw another point right here. And maybe the point right here is the same thing, distance in F. And so we have a point right here. Let's see if we can draw this parabola. It's not going to be perfect now. See, I'm even missing the points I put there. There's the parabola. So let's take a look at some of the things on this parabola. So suppose this had a distance of 6. Well, then that would mean this has a distance of 6. And if this right here has a distance of 7, then that means that right there has a distance of 7 as well. So that is how a parabola is formed. It's formed with this dot right here called F and that line there called D. Okay, let's do some more definitions. The point F is called the focus and the line D is called the directrix. The vertex V, and we might recognize that from earlier, is the point of the parabola closest to the focus. So this point is actually the closest to the focus, and we call it V. The focal length is the distance from V to F. And so I would ask, what is the focal length of this parabola? The focal length, we'll write this down, focal length of this parabola. Well, let's think about this. The distance from here down to there is 6, and so the distance from the focus down to the directrix is 6. The focal length is the distance from V to F, so we could say this right here is 3. See, it's half of 6. So the focal length is 3. Okay, the next thing, kind of a weird definition that they're going to have here is, I'm trying to find my blue highlighter. I don't have it. I'll just use the orange one. The lattice rectum. I didn't come up with this. It's the chord parallel to D which contains F. So the lattice rectum is actually this right here. It's that line segment right there. The focal diameter is the length of the lattice rectum. So how long is this line segment? That is the focal diameter. So the focal diameter on this happens to be what? Well, we have a 6 right there. We know that that's 6. So it is 12. And so those are all the definitions. It's kind of weird because on a circle we have this thing called the radius, and we point to it and say, there's the radius. And then we also say, what is the radius? And we say, oh, the radius is 5 feet. Over here, the focal diameter is 12. And, you know, it would be nice to just call that line segment the focal diameter, because that would be kind of similar to the circle. But we don't say that that line segment is the focal diameter. We say it is the lattice rectum. So I know it's kind of like weird making that distinction, but it is what it is. So that is what the parabola is. Let's go ahead and ask the question, is there a relationship between the focal diameter and the focal length? Well, in this case it looks like 4 times the focal length is the focal diameter, and in fact we can always say that. So we can say that the focal diameter, and I'll abbreviate it, is 4 times the focal length. Okay, and so there it is. Some applications of parabolas would be satellite dishes, flashlights. There's actual applications of parabolas where you can use this shape for things, like we said with flashlights and satellite dishes. So let's go ahead and put up our next paper here. And what we're going to do now is a derivation, and this derivation is going to be the derivation of the parabola. I'm going to stop this because it looks a little focused, and I'm going to merge some videos together. Okay, so there is a parabola. I've centered it at 0, 0. So here's the vertex. It's at 0, 0, and it has a focus of 0p. There's the directrix. And I'm going to pick any point on the parabola. So any point on the parabola, we'll just call it xy. So you can pick the point there, or pick it there, or pick it there. I'm going to pick the point right here. And I'm going to say that this distance here, maybe I should get out the ruler here. This distance here. So what I'm doing now is a derivation, and for those of you who are like, yeah, I don't need this, you can just skip on ahead on the video. Those two line segments are the same. They're equal. That's what I mean. They have equal length. And so I'm going to pick the point. I'm just going to say it's xy, and it could have been any point on that parabola. So there happens to be a point down here, and that point down there has the same x or y coordinate as this one. Has the same x coordinate, so it's x, comma, and the y coordinate happens to be -p. So this is going to get so abstract, it's going to make some of you sick, but here it goes. How do we say that this distance equals that distance? Well, let's write it out. The distance from 0, p, to x, y, so it's just a way of saying the distance of that, equals the distance from x negative p to xy. And I could have put these guys in any order, I just chose to put them in that order. Okay, so yes, the image is looking a little clearer. I like this. So, do we know how to find the distance between 2 points? And the answer is yes, we have the distance formula. I'm going to go ahead and plug these guys into the distance formula. I'm not going to write out the whole formula this time, since this is just a derivation. I'm going to go x, that's the x2 really, minus x1. So x2 minus x1 squared plus y2 minus y1, and in this case it would be y minus p squared. This equals, now we're going to go ahead and do the distance formula between these 2 points. X2 minus x1, that's x minus x squared, plus y2, which is y minus y1, so that's going to be y minus a negative p, it's y plus p squared. Okay, on the left hand side, I end up getting square root of x squared plus y minus p squared. And on the right hand side, that is 0, and I'm just going to be left with square root of y plus p squared. Okay, I'm going to go ahead and square both sides here. What I end up getting is x squared plus y minus p squared equals y plus p squared. So I'm trying to get an equation of this parabola, and I know that some of you are like, hey, that equation is y equals x squared, but is it, and how is it related to the focus? So we don't know, and that's what we're doing now. I'm going to go ahead and multiply, or expand the y minus p times y minus p, so this is going to give me y squared minus 2py plus p squared. This is going to equal, here's a FOIL over here, y squared plus 2py plus p squared. Okay, I'm going to subtract p squared on both sides. Those guys are gone. I'm going to subtract y squared on both sides. Those guys are gone. I'm going to add a 2py on both sides, and I end up getting x squared equals 4py. And there's the result we were looking for. All that work to get that. Okay, so what do we have here? P is a directed distance. So P gives the direction and distance, and we have to pay attention to this, from the vertex V to the focus F. So remember, this is the vertex and this is the focus. And so sometimes P could be negative, and if P was negative, the parabola, the focus would be below, and the directrix would be above, and the parabola would open down. So let's just put that when P is positive, then the parabola opens up, and when P is negative, the parabola opens down. Okay, the focal length, we talked about that. the focal length is the distance from V to F, from the vertex to the focus. So a lot of us would say, oh, well, that equals P, but since the focal length is just a distance, it's not a directed distance, it's going to be the absolute value of P. And the focal diameter, which is 4 times the focal length, we can write as absolute value for P. And so, yes, this was a derivation. You don't have to know how to do this derivation to do the homework. What I'm going to do is put a sheet up here that has some important elements of what we've done. Now, notice, before we totally get rid of the sheet, what we have on some of these formulas here, you know, how this one differs from this one, is this parabola here is going to have a vertex of hk. And in my parabola, the vertex was 0, 0, and you can kind of see that there's no h and k. You don't see parentheses or anything. And so this is going to actually be more general. So let's take a look at what we have here. So we have our up or down parabolas, which will always have an x squared in them, and then the y will not be squared. And I know this is a shocker. We're going to have right or left parabolas where the squared is on the y and x does not have a square. The vertex is always going to be h, k, and the h is kind of married to the x and the k is married to the y, so remember that. P gives the direction and distance from V to F. We kind of wrote that down on the other page, but here it's all written up, typed up. The focal length is the absolute value of P, and the focal diameter is the absolute value of 4P. This is what we have to know to do some problems. So the rest of what we do in 7.3 will be just working out some problems. So in your homework, they're going to ask you problems that look like this. Graph the parabola, find the vertex, the focus, the directrix, and the endpoints of the lattice rectum. And that's what we have to do. So we'll do a few of these problems. X squared equals 8 times y minus 3. And I know we have not really been seeing our parabolas like this. A lot of you want to solve for y. When you do that, if you do that, you're going to lose some aspects of the focus and the directrix. So let's go ahead and see maybe the formula that this falls into. It falls into this formula. So this is from that last sheet that I had that was typewritten. X minus h squared equals 4p, and we have y minus k. Okay, so you kind of see that it fits in that mold, and that would mean that this parabola is an up or down parabola. Okay, so it's either going to open up or open down. Let's go ahead and identify a few things. We have that right there, that right there. So we can see from this example, from our example, that 4p is going to equal 8. So p will equal 2, and that's going to be kind of important. They never asked the value of p, but this is going to help us with this parabola. Okay, so let's find the vertex. We probably could have done that right away. The vertex, we'll just make a v there. It's going to be hk. In this case, h, it doesn't seem to be there, but it really says this is really x minus 0 quantity squared. So the first coordinate of the vertex is 0, and then with the formula, you're always taking the opposite number that you see there. So you see y minus 3, so you're going to go with a 3. So we found the vertex. Okay, what we might want to do, some of you might want to do this just to get a visual in terms of what you need to do. So I'm going to go ahead and start putting the graph right over here. so the vertex is 0, 3. So 0, 1, 2, 3. Now I'm not going to graph the parabola, but I'm just going to put the vertex there. And P is 2. So remember how we said that this parabola opens up or down? Because P is positive, we know that the parabola is going to open up and not down. That 2 is going to give us a good start on this. So here's X, here's Y. To get the focus, you move up 2. And I'm going to put a star, like this kind of star here, where the focus should be. So there's the focus. And the focus actually has some coordinates. You could actually look at this. It looks like it's 0, 5. So there is the focus. So the vertex seems to be the middle. We go up to and get to the focus. We go down to and get to the directrix. So I'll make the directrix be in purple. I don't know if you can even tell. We'll do this anyway. So there's the directrix. And that happens to be, so this has 3 and this is 1. So this actually has the equation, the directrix, of you're at 1 and it's a horizontal line, it's y equals 1. So the directrix, I'll just write a D there. I'm losing my voice here. This is going to be y equals 1. So I know what you're thinking. We already had a few parabolas that look like this. Let's go ahead and graph it. Before we graph it, we're going to try to find the endpoints of the lattice rectum. Okay? So the endpoints of the lattice rectum. Okay. So how are we going to do that? Well, the lattice rectum has, the length of it is called the focal diameter. So the focal diameter happens to be the absolute value of 4p. And we have the absolute value of 4 times 2, because 2 is the value of p. So this is the absolute value of 8, which is just 8. So that happens to be the endpoints of the lattice rectum. So what we're going to do is we're going to go up. Let me actually use a pencil, and I'm not saying that this is anything significant on the graph. Let's go like that. And the endpoints of the lattice rectum will be on that line there. And I'm using the focus as sort of the center of that. So here's the focus. Here's the vertex and the directrix. And so what I'm going to do, if it has length 8, a lot of people make the mistake and they go right from here and they count out 8 this way and 8 that way. And that would make a mistake, because then you would actually have the focal diameter being 16. So you want to go to the right 4, and that gives you half of it, and then to the left 4. And so that's what I'm going to do. So I'm on the x-axis. 1, 2, 3, 4. 2, 3, 4. And so let's go ahead and put a point right there and a point right here. Now those endpoints happen to be 4, 5. And the other one is -4, 5 as well. Now what we could have done is we were thinking about this, write ±4, 5 for this example. Okay, so now like I was saying, this line right here is not really significant. I drew it, so I just smeared the dot. I drew it so we could see where those points lie, which horizontal point. Oh man, what a mess this is. Here, let's clean it up with some white out. There, now, no one will even know. So the reason why it's good to graph those is now you know how wide to make your parabola. And let's go ahead and draw it. And there it is. So that completes problem number 1, where we're graphing the parabola, finding the vertex, the focus, the directrix, and the endpoints of the lattice rectum. So we're going to do another problem, probably do 2 more of these kinds of problems. And the thing that's really going to stink about, like the next problem, is the fact that some of these numbers are going to have fractions. And it's really the fractions that hurt us. Also know that some teachers take an algebraic approach to these problems, and they would say the focus is 0, and then they put the vertex plus p, and you know, they do more things algebraically. I'm doing things visually. If I try to do things both ways, it gets confusing, you know, because then people think they have to do the problems like 2 different ways. Let's go ahead and do problem number 2. Let's see how our time is doing. Okay. So graph the parabola and find the vertex, focus, directrix, etc. Oh, one last thing about this is this number right here will always be the focal diameter. If it's negative, then it will be the absolute value of that. Okay, so that's going to be a quicker way to get some of the problems done. So we know the focal diameter on this one's going to be not -3, but 3. Okay, so when we get to that, maybe we'll notice that again. Okay, so we know that this guy right here happens to be 4p. Okay, so I'll do what I did in the last problem. 4p equals -3. P, there's an airplane, equals -3/4. I'll circle it. I don't want to forget that. That's going to help me. And before we move on to the vertex and all that stuff, we see that the x has a squared on it and the y doesn't. So this parabola will either open up or down. And because p is a negative number, it means that the parabola opens down. Okay, let's go ahead and find the vertex. The vertex of this parabola, we have hk, so this is going to be 2, because it's the opposite of what you see in there. And then -3. So there's the vertex. If you want, you could start drawing this parabola. You don't have to do it this way, but I'm going to do it this way. So here's x, here's y. I have the point 2, -3. I'm going to put that right here. I know the parabola is going to open down, so it's going to go like that. I'm not going to draw it until I get those endpoints, but at least now I know where to go from. Okay, the next thing that I want to do is find the focus. And visually I know where it's going to be because the P tells me the direction and the distance. The focus is going to be down over here. Okay, so let's put another tick mark. Here's -3, here's -4. So to get the focus, you're going to go down by 3/4. What coordinate is that going to affect? Is it going to affect the x coordinate or the y coordinate? And the answer is it's going to affect the y coordinate. You're actually going to go -3 -3/4. Now a lot of you can say that's -3 3/4, and that is correct. I'm going to go ahead and get a common denominator, and I'm going to call this thing, let's see, this is negative 12 fourths, 13, 14, 15, so this is going to be negative 15 fourths. Or you could say negative 3 and 3 fourths. So the focus, I'm not going to put it right at negative 4, I'm going to put it a little above. I'm going to put a star there, and there it is. Okay, let's go ahead and write that out. It shares the same x coordinate as the vertex, so I'll put in a 2 there. And the y coordinate's going to be that right there, negative 15 fourths. And I tell you, the fractions on this problem, it's kind of a bummer. But this sometimes happens. Okay, now to find the directrix. The directrix is on the other side of the vertex. So the focus, you go 3 fourths down. With the directrix, so we're at negative 3, you go 3 fourths up. So you could say minus p, you know, because minus p would be minus negative that. I'm just going to go plus 3 fourths. Now you can say, oh, I know what that is. That's negative 2 and a fourth. And that's correct. Negative 2 and a fourth would be between negative 2 and negative 3. I'm going to go ahead and get a common denominator, and I'm going to get 9 fourths when I do that. And so that's this right here. You know, let me go ahead and make it in purple. So negative 2 and a fourth puts me, you know, like right here. I just want to make sure this is kind of precise. And so there is the directrix. Okay, so we have the directrix, we have the focus, and then there's the vertex there. I'm not going to label it V because I don't want it to get too cluttered. And so this directrix has an equation. It's horizontal, so it's y equals. What does y equal? Negative 9 fourths. Okay, now I have to find the endpoints of the lattice rectum. And so to do that, now I go to the focus. So I'm going to focus on the focus. And I'm going to move to the right and to the left. So it's going to be along this line. And, you know, remember I erased the other one and made smudge marks, but that's where the lattice rectum is. And so we have to figure out, well, what is the focal diameter? Focal diameter, it is the absolute value of 4p. But remember, that's just this number here in orange. So it's the absolute value of negative 3, which is 3. Now if you'd like, you can say 4 times this, and then you'd get the same answer. So once again, we don't want to say let's go 3 to the left and 3 to the right, because then that would give us 6 for the focal diameter. We want 3 for the focal diameter. So we want to go 1.5 to the right and 1.5 to the left. And the number that we're going to be concerned with now is this 2, because that's where we are in terms of the x-axis. So if I went 1.5, so I'm going to go 2 plus 1.5, which is really 3 halves. It's half of that, 3 over 2, and then 2 minus 3 halves. So the fractions are kind of ruining the whole day on this. So you could say that this right here is 3.5. Let me write that down. You know, some of you prefer that, the mixed numbers. It's actually 7 halves if you want to write it as an improper fraction. And so, you know, I'm going to go 3, 4, and I'm going to put a little mark right halfway between there. So this is one of the endpoints. And then the other one, maybe you can see that 2 minus 1.5 is 1/2. And so I'm going to try to put the point right there. And so the endpoints of lattice rectum happen to be, so they all have the same y value as the focus. So they're all going to be like comma negative 15/4, which is pretty ugly. I mean, that's what it is. And so the one of them is going to be 7/2 negative 15/4, and the other one's going to be 1/2 negative 15/4. Once again, the fractions, I think they are ruining the day, but I don't want to just do the nice integer ones and then in the homework you're like, what just happened? So we're pretty much done with this problem, except now I've got to connect those 3 points and make the parabola. That's what I'm going to do. And that's going to be good enough. Normally we'd say, hey, find the intercepts. We've already had enough trauma. This will be good enough. So this completes problem number 2. Let's go ahead and do problem number 3, which I don't think is bad as this in terms of the arithmetic and the fractions. So here it is, problem number 3. Okay, another one. Now notice on this one, it's our first one where it says y squared and x is not squared. So this is going to open right or left. Okay, so that's what we'll determine that. Okay, once again, I'll try to keep the same colors going here. That right there is 4p. So 4p equals negative 12. P equals negative 3. I'll circle that. That's a directed distance from the vertex to the focus. And since it's negative, the parabola is going to open in a negative direction, which means it's going to open, the negative direction would be to the left. Okay. So let's go ahead and find some of the things. You'll notice that, if you look at the PDFs of these pieces of paper, that I'm pretty much doing the same thing, except the numbers are different or the parabola opens in a different direction. But it will always open one of 4 directions in this section: left, right, up, or down. Okay, the vertex, a lot of people want to shout out maybe to negative 1. But you got to remember, the x-coordinate of the vertex is married to that x. So it's going to be negative 1, and then the y-coordinate is going to be 2. So the vertex is negative 1, 2. At this moment, you could start drawing the parabola. There's x. Here's y. And I have negative 1, 2. There's the vertex. Okay, so now I'm going to use this. The vertex is sort of the center at the beginning of what we're finding. We're going to use this to find other things, and we're also going to use this p equals negative 3. In fact, that's where I'm going to go next. P equals negative 3 is the directed distance from here to the focus. So I'm going to move over. I'm at negative 1 here. I'm going to move over 3. So 1, 2, 3. Now I'm at negative 4, and I'm going to put like a star there. Okay, so that gives me the focus. And the focus then would have the coordinates negative 4, comma 2. Okay, the directrix is going to be the line on the other side. So when we went 3 to the left to find the focus, now we're going to go 3 to the right to find the directrix. 1, 2, 3, which brings me right here. And now the kind of line I'm going to make is a vertical line. This is the directrix, And the Directrix actually has the equation not y equals, but it's going to be x equals 2. Okay, and the last thing that I want to find, so these should be equal. This should be equal distance here, from here to here and here to here. And I'm not using grid paper, but if I was, it would look nicer. The lattice rectum is going to be along this line. This is not the Directrix. This is just where the lattice rectum is going to be. And we want to find the endpoints. Well, the length of the lattice rectum happens to be the focal diameter, which is the absolute value for p. And there's the 4p right there. It's negative 12. So the focal diameter is 12, which means I'm not going to go up 12 and down 12. I'm going to go up 6 and down 6. Now, teachers who teach more algebraic approach, they would go, oh, we would go like this. We'd say negative 4. I don't know if you can see that on the video. Plus or minus 6. No, they wouldn't do that. Good thing I used a pencil with a very bad eraser too. They would say negative 4, and then they'd say 2 plus or minus 6. You know, and so they would take a more algebraic approach. I'm a picture person, so this is the approach I'm going to take. I'm not this way here. I'm going to say, okay, I'm right here, so I'm going to go up, not 12, but go up 6. So 1, 2, 3, 4, 5, 6. So I went from 2 to 8, and I'm going to put a dot. And so the endpoints of LR happen to be negative 4, 8, and then I'm going to go down 6. So 1, 2, 3, 4, 5, 6, which takes me to negative 4 for my altitude. I'll put that right there. And so this point looks like it's negative 4, negative 4. So now all I have to do is draw this parabola that's opening to the left. Now I'm going to turn this because I'm going to draw it wrong if I can't have it at the correct angle here. And then I'm going to go like this. And so that completes the drawing, and that's a real true parabola. The distance from focus to any point on that parabola hopefully is the same as the distance from that point on the parabola to the Directrix. And so those are the first 3 problems, and I would have to say that these problems are probably going to be more difficult than maybe some of the other problems that follow. Let's go ahead and do problem number 4. It says find the standard form equation of the parabola that has vertex 2, 1 and focus 7, 1. So how am I supposed to do this? Okay, the way I do these problems, so did it ask for a graph on this one? No, it didn't. So this is not part of my answer. This is just me trying to figure out what to do here. So it has a vertex of 2, 1 and a focus of 7, 1. So which way is the parabola opening? Well, it always opens toward the focus. Now I know what you're thinking. You're like, Joe, whoa, I've just moved the camera. See how that affects things. Move it back. You might say, well, you didn't put the endpoints of the lattice rectum. I don't care. That's just asking for the standard form equation of the parabola. The standard form equation is the ones that we showed on that typewritten sheet. So this parabola opens to the right, which means it's going to be, the square is going to be on which one? The square is going to be on the y. So I'll go ahead and write up that equation, y minus k squared equals 4p x minus h. So there's the standard form of the parabola. And we already know what h and k are. They happen to be 2, 1. So you gotta get these guys right. This one is h, this one is k. Now we also know something else from the picture, that the distance from the vertex to the focus is what? It's this distance right here is 5. So we know the value of p. P is going to be a directed distance and it's going 5 to the right, so it's going to be positive 5. And we got that from our picture. You know, we got that because we knew where the focus was. So let's see if we can write this out. This is y minus 1 squared equals 4 times 5. And we have x minus 2. So this is y minus 1 squared equals 20 x minus 2. Now the funny part about this is that is your answer. You're not going to try to distribute the 20. This is exactly how they want the answer, and you're done. We found the standard form equation of the parabola. Let's go ahead and do the next problem. Problem number 5. Find the standard form equation and then find the vertex, focus, and directrix. Now the problem with this one is this is not written in standard form. And so we have to figure out how we write this in standard form. And we're going to kind of do what we did in 7.2. We're going to be completing the square. So how do we complete the square? What we want to do is find out which one has a square, which is the x's, and keep all the x's on the left-hand side of the equation. So this is 2x squared plus 12x. Leave a space. This is going to equal negative y minus 20. Okay, now if you start completing the square and saying 12 divided by 2 and then square it, you're kind of off because you cannot complete the square unless there's a 1 in front of the x squared. So what are we going to do to everything in the equation? Divide it by 2. So now I have x squared plus 6x. This equals negative y over 2 minus 10. Okay, so now it's time to complete the square. We're going to go ahead and take the number, this number here, 6, and we're going to chop it in half and square it. And we kind of went over this in 7.2. So this is 3 squared, which is 9. 9 is the magic number. I'm going to add it right here, and there's really nothing magic about this. This is math. But we just say that anyway, I guess. This left-hand side becomes a perfect square trinomial, x plus 3 quantity squared. And the 3 is the same thing that you see there. That will always happen. This equals negative y over 2, and then this is minus 1. Okay, and I actually go back to the black ink. So at this point you're thinking, we're in standard form because we have this squared. Our standard form must look like this. X minus h squared, which we have there, equals 4p y minus k, which we do not have there. So what I'm going to do on this is I'm going to factor out a negative 1/2. That's what I'm going to do because that's the thing that's right in front of the y. And so that's what I have. Now, when I'm factoring out a negative 1/2, that could be difficult for some people in here. And so Factoring out a negative 1/2 is like multiplying everything here by the reciprocal to see what we get. So, like, I've got this negative y over 2 minus 1. So off to the side, to see what goes in here, I'm going to, the reciprocal of this is flipping that fraction. So it's actually a negative 2. So to see what goes in here, look at this. We end up getting the 2's canceled, we end up getting a y, and then this is a plus 2. So that's what goes inside the parentheses. So this is going to say y plus 2. Now some of you were able to just figure that out just because you're thinking backwards, which is all right. And so this right here is the equation in standard form of the parabola. Find the vertex. That shouldn't be that hard to find now. It's going to be, we look at that, negative 3, the opposite of what you see there, and then this is negative 2. Okay, what is p in this example? Well, we know that 4p equals negative 1/2. So p equals negative 1/8. Okay, what are we going to do about that? I'm going to draw a really crude drawing here. We have the vertex is right here, negative 3, negative 2. And we have a p is negative 1/8. We know this parabola is going to open down. It's an x squared and there's a negative. So opens down. And because it's opening down, the focus is going to be right there. Now there's fractions in here, so we don't like this. So the focus is going to have the same, you have to think, is it going to be the same x coordinate, which is negative 3, or the same y coordinate, which is negative 2? If you take the point and shift and move it down a little, it's going to have the same x coordinate. To get the y coordinate, you're going to say negative 2 minus an 8th. And so this is negative 16 over 8 minus 1/8, which is negative 17 over 8. I know I'm kind of going, hopefully not out of range, but here's negative 17 over 8. That gives me the focus. Let's go ahead and do the directrix. The vertex was negative 3, negative 2. So the directrix is going to be a line that goes right above here. And so it's going to be negative 2. Instead of minus an 8th, we're going to add an 8th. So negative 16 over 8 plus 1/8, which gives me negative 15/8. So the directrix, so this is what gives me the directrix. That's what gives me the focus. Is going to be the line. It's a horizontal line. Y equals negative 15/8. So wow, we did this problem. The thing that kind of ruined it in terms of the last part was finding something with a fraction, and we completed the square. So what I want to do is another one where we're just completing the square. So I just want standard form on the next problem. You might decide to pause the video to see if you can do this on your own. Okay, so let's go ahead and do this problem. Keep your y's on one side. Leave a space and put your x's and everything else, the non-y's, on the other side. So this is going to be negative 4x minus 67. then I'm going to realize, whoa, I need to have a 1 there. So I'm going to divide everything in that equation by 3 to get a 1 in front of the y squared. Okay, so this gives me y squared minus 10y. This is going to equal negative 4/3 x minus 67 over 3. Okay. So what I'm going to do next is complete the square. I have this negative 10. I'm going to chop it in half and square it. So this is negative 5 squared, which gives me 25. That's the magic number. So I'm going to add 25 there and add 25 to the right. Left hand side is going to factor into a perfect square trinomial. Let's see, y minus 5, and I can see that right there, squared. And the right hand side we have minus 4/3 x. I want to put these together by getting a common denominator of, I guess, 3. So that looks like 75 minus 67. So that looks like maybe an 8 over 3. Okay, so this is not in standard form yet until it looks like this, until it looks like y minus k squared equals 4p x minus h. Okay, so I have to factor out a negative 4/3. Okay, so some of you already know what to put there, but for those of you who do not, I'm going to go ahead and take this thing that I'm trying to factor out, and to get what number goes there, I'm going to multiply this by the reciprocal. So this is going to be negative 3 over 4. So that's going to give me an x, and then minus 4 cancels with the 8, so there's a 2 there, and the 3's cancel, so this is going to be x minus 2. And so that's what goes there. Now, if you're ever unsure, just go ahead and multiply that through, and you'll end up getting what we see above. So here's the standard form of the parabola. And I said that's all I would do on this problem, but I just want you to tell me, or to write down on the piece of paper, what the vertex of that parabola is. Well, the vertex of that parabola is going to be not 5, 2, but it's going to be 2, 5. Now, if you were to find some other things like the focus and the directrix, you would have to find p first. And p is not negative 4/3, but that's what 4p equals. Negative 4/3, and p would equal negative 1/3. And so you can figure out what the focus is and what the directrix is. This parabola opens which way. It's going to be a left or right one, and it's going to actually open to the left. Opens left. So if you want it, I'll put the answers down here and you can verify this, that the focus would then be, let's see, opens to the left. We have 2, 5. Let's just go ahead and do this, okay? I know I'm done, and maybe I should just go ahead and work this all out just so we have it, okay? So I have this parabola that is 2, 5, and my scaling looks really bad. And so there that is. And it opens to the left, so it's opening like that. And the focus is going to be right here. I'll find the focus by going, so let's see, the focus is going to have the same x or y value as the vertex. It's going to have the same y value. And to get the x value, I'm going to go 2 minus 1/3, which is 1 2/3, or you could say 5/3. So this is 5/3. I wasn't planning on doing this, but I figured, we'll just do this. I mean, that's all YouTube needs is more video of boring math. I mean, just think of this whole pandemic when it happens and all these people are scrambling to make videos, all these mediocre math videos, and mine's just as mediocre as all the others. What a waste. Complete waste. Maybe, I don't know. If it's helping one of you guys, then great, but hopefully we don't have other people not in my class watching this for entertainment or wow. I don't know what to say about that. The Directrix, I'm going to actually go 2 plus 1/3. It's going to be a vertical line, so the Directrix is going to be x equals 6/3 plus 1/3 is 7/3. Okay, so I went ahead and found everything, even though I wasn't planning on doing that. But the important part was completing the square and putting it in standard form. Let's go ahead and do an application problem, and that will finish off 7.3. And the application problem has a light. So we have a circle of diameter 8 centimeters, and we have a parabolic dish. Okay, it's like taking a parabola and rotating it. So we have that. You may have seen things like this on the roof of your house, or a satellite dish or something in a flashlight. And then this length right here is 5 centimeters. Where should the light bulb be placed so that it is at the focus? So what I'm going to do is, notice this right here, this looks just like a parabola, and it is. I'm going to take that parabola and put it on one of these graphs here. Okay? Now I could put this vertex wherever. I mean, I could put the vertex over here at 10, -7. But it's just going to make the calculations a lot more complicated. So I'm going to go put the vertex, that vertex right there, and then I'm going to go ahead and draw the parabola up. Now, before I do that, let's think about this. This right here, and this right here, we want to know what this point is. It says this top part is a circle of diameter 8. The diameter goes all the way across. So to get to that point from here, I'm not going to go 8 over, I'm only going to go 4 over. And then we're going to go 5 up. And so that's kind of like what my parabola is looking like. Okay, just drawing it really fast. So the parabola has the point 4, 5. And so we know that this parabola opens up. So it's going to be an x squared parabola. Now, because I chose to put the vertex HK at 0, 0, it's going to be a lot simpler. So really, all I need to find to complete this problem, well, I have to find out what P is, because P is the distance from the vertex to the focus, and they're saying where should the light bulb be placed so that it is at the focus. So let's go ahead and find out what P is. How do I figure out what P is? I put a point that's on that parabola in there. Now if I put 0, 0 in there, it's going to ruin all my data. I'm going to put 4, 5 in there. So make sure you plug the things in correctly. X squared, so that's 4 squared equals 4, P, and then Y is 5. So I have 16 equals 20P. P equals 16 over 20. P equals 4/5. So the answer to this, so 4/5 is right here. Now we kind of go back to this. That's where the focus is. Where should the light bulb be placed so that it is at the focus? We're going to say 4/5 centimeters above the vertex. There's the answer. Now the whole rationale behind that is you have the focus here, and when the light goes on, because of the way the parabola is, the light's going to go like this and bounce straight. So like if it went over here, because of the curve of that parabola, it's going to go like this, and like right here, and like right here. You don't have to draw this picture. So all the light's going to be directed straight out. And so that's why we like parabolic dishes, for lights and also for things that come in. You know, like you have a lot of data coming in from space and it hits the parabola like this, or straight down. That information is going to get directed to the focus, and then we'll have the data that way. So yes, there are applications of things that you do in your math class. And that completes 7.3, which is a huge section, parabolas. What made it new was the focus and the directrix and things like that. You guys have a good day. I'll see you next time.